3, 2, 1.
Zero. All engine running. Liftoff. We have a liftoff.
In this video series we are going to explore all the commonly presented evidences to prove that the Apollo missions were a hoax. However, there are a lot of misconceptions surrounding this topic, so our job will be to separate the weak evidences from the solid evidences, or what we like to call, the real smoking guns, from the not-so-smoking guns. So join us now on this adventure, as we go into the lies which NASA has told, in order to cover up the truth which they are trying to hide from us.
Tranquility Base here. The Eagle has landed.
I am joined by Dr. Rasaviharii.
Yes, Rasa. You can just call me Rasa.
All right. Super stoked to have you on today. I think I found the Apollo Detectives YouTube channel on a Twitter link. Someone posted it on Twitter, checked it out, and that's how I came across your presentation. And I was truly, truly blown away by your knowledge. Many of the rabbit holes that you go down, I also go down. And so I just I got to try to reach out and get Dr. Raz on. Now, if you could give us a little bit of background of who you are, what you do, all that jazz, that would be awesome.
Okay, well, mainly I'm a physicist. I work in the area of what you call free energy or 0-point energy. I'm also the admin of this Facebook group called the Moon Landing Hoax. You have to search a moon-landing hoax. And also we have a YouTube page also called moon-landing hoax. And I also have another YouTube page which is called 0-point energy. So that's it. You know, I live in China. I'm working with the Chinese Space Agency on the protection from radiation in deep space. So I have a lot of knowledge about space travel. You know, I'm an astrophysicist, and also I'm a historian. I'm writing a book now about the history of the private central bankers.
That's awesome. Now, you said you're an astrophysicist. I've heard Neil deGrasse Tyson say in the past that there's not very many in the world. So that's pretty awesome. I can't remember what number he gave. It wasn't more than 1,000, if I remember correctly. There's only like a few hundred. According to him, anyways. He is full of shit on many other things, so who knows? But I did want to ask you about, is that true?
I don't know. I would think there'd be many more. You have NASA and the European Space Agency, Russian Space Agency, India, China, Japan. There must be a lot of people who studied astrophysics to get a job like that.
Yeah, the moon landing for me is something that I came into rather late, just only a few years. I think once I started having distrust for government in general, you know, I started looking at many other subjects like 9/11. I've been wanting to have a show like this, you know, regarding the moon landings, and what better person, in my opinion, to have an actual astrophysicist, someone that is super knowledgeable and works in this tech, and someone that doesn't believe in landings. So give us a little bit of background. What got you down this rabbit hole? It seems like it was several years ago, right?
Actually, it really began when I was age 7. There was what was called the Iranian hostage crisis and the Iranian Revolution. And I was just 7 years old, but my mother taught me these guys are just trying to get Carter out of office because Carter was an anti-war president. Mm-hmm. So they organized this Iranian hostage crisis in order to smear his name. So I was just 7 years old when I learned that the government was lying and cheating. And I was offered a job at NASA in 1999, but I turned them down because that I'm leaving the country. I don't like this country. Then later, in 2001, I happened to be in New York City when 9/11 happened. But what happened regarding the moon landings was I saw Bart Sibrel's documentary. A funny thing happened on the way to a moon, and that other one, what happened on the moon back in 2001. But me being a scientist and having a background in astrophysics, that was a little hard to believe. I was like, whoa, wait a minute. That's going a little far with the moon landing being a hoax. So it was very difficult for me to consider that seriously. But then what happened was I was going to fly from America to India, and I was getting on my airplane at the JFK airport in New York City. And as I was walking to my plane, they had this full-size, life-size image of the man on the moon in the airport. And then you can see the astronaut and the mountains in the background. And you had the forescreen and the back screen. So if you can look at that image, life-size, extremely high resolution, blown up life-size, you can see that the mountains in the background and the forescreen, there's a different grains, how to say, camera grains. The grains on the ground he's standing changes when it's in the background. You can't see this on a computer screen, but maybe if you ever go to the JFK airport in New York, you can see this full life-size image. You can stand next to him and take your picture, and he's the same size as you. And when you see that clarity, you can see the background and the foreground are a different image. And so I was convinced at that time. So from 2001, what I would like to present today is this list which I call the 12 smoking guns. And the reason I made this list is to help people like yourself present a stronger case, because there's what I call two categories. One is the smoking guns, and one is the things which make you go, So for example, you were talking about the lunar lander, it looks flimsy. These are things which make you go, It's not really a smoking gun, because they're always going to have excuses for that. Well, there's no atmosphere in space, so the ship doesn't need to be strong. That would be the excuse they give. So what I would like to present now is what I call the real smoking guns, which are the strongest pieces of evidence that even the NASA fanboys or the trolls, they can't even defend against these, because if they did, they would just be making fools of themselves. It's so obvious when you find flaws in the photographic and video evidence, then there's no refuting. So first of all, let me say I have this list which I call 12 smoking guns, and there obviously are more than 12, but these are just the 12 which I call the strongest arguments. And also, this is just a really quick list. For each one of these points, I'm going to present one or two different examples, but there's many more. So I'm giving this to you so you can start doing your own research. So let's start off here. I'm going to share my screen, and we're starting with what I call diverging shadows. So you can see the astronaut on the moon, right?
Yes, sir.
So first thing to mention is it's always important to write the number of the image. So this is AS14-68-9487. I'm just saying that because a lot of people come in my group and they're like showing an image and it's like, what's the image number? It's important so other people can find it and research it. So what we're showing here, you see the two red lines is showing the direction of the shadows, right? So the ship is creating a shadow this way, and these rocks are creating a shadow that way. So that's what we call diverging shadows. So this is absolute proof of a close light source, okay? This is not the sun. The sun cannot do this. Now, let me explain this a little bit. First of all, it's important to know what would the excuse that the trolls try to make for this. They would try to say, oh, this is due to uneven ground. So let me try to explain that point. Let's say you have a ground. Let's say you're on a hill, okay? And the hill is shaped like this, right? And then you have two people, one standing on this side of the hill and one standing on that side of the hill. that would create diverging shadows. But if the ground was curved like this, and you had two people, then their shadows would be converging, right? But you can tell from the image, this is not a hill like that. It's not a hill like this. This is a flat land, okay? So this excuse about uneven ground, it doesn't work. Now I'm going to show another example of this. So here's another example, the famous Buzz Aldrin flag salute. So again, you can see the shadows are diverging. You can see that, right?
Yeah.
You have the ship shadow, you have his shadow, and you have this rock shadow, and they're not parallel. They're all coming from a very close light source. Now, let me just come back here, because there's one important point I want to say here, is there are other moon landing researchers who are presenting images, which they also call smoking guns, and it's showing these converging shadows. This is not a smoking gun, because in order for it to be a smoking gun, the camera and the light source has to be at a 90-degree angle. The person taking the photo has to be at a 90-degree angle from the light source, because if the person taking the photo is looking towards the light source or looking away from the light source, then you're going to have what's called perspective. And perspective means if you're standing on a railroad tracks, you see the railroad tracks converging into the distance, right? So that's perspective. So if there's an image where the light is at your back or the light is at your front, you're going to have perspective. So you can't use this as a proof of a hoax. And sometimes, some people are pointing out different rocks, well, this rock has a shadow pointing this way, and that rock has a shadow pointing this way. This is all just strange shaped rocks. Again, this is not proof of a hoax. So that covers my first smoking gun here. The next one is the famous ladder jump. Now, the ladder jump, see, I had personally discovered this smoking gun on my own. And then later on, it came out on this movie, American Moon. I had actually found that smoking gun before American Moon, but that doesn't really matter who found it first. So this astronaut is about to jump up onto the ladder. And when he jumps, his feet and his hands miss the ladder, and he's dangling in the air for a little while until he finally grabs the ladder. Okay, it's kind of quick, but just watch it. Jump. You see his legs dangling. Now he gets his feet onto the ladder. Okay, so you see it's very, very clear he's dangling in the air. Okay, his feet are off the ladder, his hands are off the ladder. Jump, dangling, dangling, dangling. Aha. Wow, this is a very clear proof of a hoax here. Okay, so you could see that, right? You could see him dangling
Absolutely,
in the air.
Yeah. I've been watching a lot of them, and I read the comments, and so many people are like, oh my gosh, my heart stopped when I watched this. And my perspective, I'm laughing at the comedy, it's just so hilarious to me to watch now that I don't believe in them.
Yeah, one thing is, it's always good to be skeptical. It's always good to ask yourself, maybe I'm wrong about all this.
Yeah.
Maybe it was real. Maybe it was real. But every time I keep coming back to clips like this, I'm like, no way. How could that be? He's dangling in the air from a wire and the shadows are diverging. There's no way to refute these things,
Right.
So now let's go to the point number 3. This one is a really interesting point here. So this is the famous Apollo 12 docking scene. Watch this antenna up here, flopping, dangling, and it's waving around. This is clear sign of Earth's gravity. This cannot happen in space with it dangling like that. This is a proof of gravity. You see, the ship is turning, and when it turns, the antenna drops, and then it wiggles like that. And this is a clear sign of gravity. Okay, this cannot happen in space where there's no gravity. I'm using official NASA clips here, okay? The person who discovered this is a member of my group. You know, he's the one who came in my group and said, check this out. The antenna is dangling. And I was, wow, this is one of the biggest smoking guns I've ever seen. And it's such a big smoking gun that NASA actually deleted this clip from their webpage. They're actually trying to hide, to hide this clip because it's such a clear smoking gun. The guy who presented this to me, I asked him, I said, have any trolls tried to come and debate you about this point? And he said, yeah. What they said is they tried to say, you're the one who sped up the film. You're the one who made it look like the hoax because you sped up the film. This is official NASA film here. This is not me speeding it up. You just saw the webpage. This is somebody took this clip from the original NASA footage before they deleted it from their webpage. Let me just show you proof that they deleted it from their webpage, okay? I'm gonna show you now the NASA webpage, and you can find this clip is missing, okay? Can you see this? Apollo 12 Lunar Surface Journal.
Yes?
So this is the official NASA webpage. Now, it says here, you know, it has here the landing day. These are clips from the day they landed. The first EVA means the first time they step out of the ship. Second EVA, and then if you go down a little bit more, background material. Here is the video and movie clips. So this is where it should be. It should be here, Apollo 12 Video Library. And here they have the first EVA. They call this a visit to the snowman. And then here is the famous quote when he first steps out of the ship. There's a famous quote, that may have been one small step for Neil, but that was a large step for me. So that's a famous quote when the first step, Apollo 12, right? This is the second time they landed on the moon. And then it's showing here, you know, his coming out of the ship and this walking around, the TV troubles. Okay, this is also part of the first EVA. And down here, wake up, get ready for EVA 2. And then there's nothing more. Where's the rest of the video clips? This video clip comes from the return to orbit, okay? So here, this is the video library. You can check all of these video clips. It's not there. It's just not there. Where is it? It should be here. Oh, we're coming back to orbit, but there's no video clips anywhere in this. So there you go. That's the biggest, one of the biggest smoking guns. So big that NASA's trying to hide it. Let's keep going now. I'm going to show you another clip. This is what I call the mannequin on the rover.
Yeah, I watched this clip personally 3 times today, and I couldn't stop laughing each and every time. So
this is Apollo 16 Lunar Apollo Flight Journal. So this is the official NASA YouTube page. Let's just watch through this thing a little bit. So you can see his hand is not even touching the steering wheel. I'm gonna come back to that point later.
yeah.
Now watch his left arm. Watch his left arm here as he drives by the camera. You can see his left arm is here. His left arm is just stuck in position. Let's see, he's going to do another pass. Watch his left arm again.
Oh boy.
His left arm is just there in the same position. So the steering wheel is in the middle between the 2 seats. Okay? It's a joystick steering wheel. You know, you push it. He has his right hand on the steering wheel, and then you go to the right, left, forward, reverse. It's a joystick steering wheel. Now, and then his left hand is just there in the air, you know? It's like it just stays there. That would be totally unnatural, you know, for a human being. Some NASA trolls tried to make the excuse that, well, this is comfortable because the pressurization of the suit, but it's not. You see, if you were bouncing around like this, you know, you wouldn't be comfortable. And then also, if you really look closely, his right hand is not even on the joystick. It's just like an inch or so above the joystick. So this is totally a mannequin that they just put on a remote control rover. They have somebody steering the rover, remote control, and there's a mannequin sitting in this strap to the seat. This is not the only time that they use the mannequin. I have a series of photographs where they were snapping pictures, what they call the pan. It's like snap, 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 snap. And then he's like snap, snap. And then you see a mannequin. And he snap, 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 snap. And all these pictures in a row, the mannequin doesn't move. So there's several examples of this mannequin. I just showed you one of when he's driving the rover. But let me just come back to one more NASA excuse here. The NASA excuse is that this is not a mannequin because he moves his arm. I'm going to show you this trick they did in order to make it not appear like a mannequin. So let me share screen again. It's just here at the beginning. So check it out. You see his arm is up in the air, right? The arm here is at a different angle from when he's driving. So you can see his left arm here at this angle. Now watch his left arm carefully. They're filming, the camera's moving around, and then all of a sudden, boom, right there. I don't know if you saw it, but now his left arm is at a different angle. Before it was at a slightly higher angle, and then now it's at the normal angle he uses when he's driving. So this is their proof that it's not a hoax. And you can clearly see where they cut the video film. His arm is up, his arm is up, arm up, cut the film, and now the arm is down. But what they're doing is the arm is up, and then they cut the film, and then they move the arm down, and then they start rolling again. It's very clear where they cut the film. So they're trying to tell, the NASA trolls are saying, this is not a mannequin because he moved his arm from up to down. But they just cut the film and they just moved the mannequin's arm down. It's very clear, you know, there's no way they can debunk this, you know.
What's your theory on why they would use a mannequin instead of a real human?
My theory is that it would just be too bumpy of a ride for an actual human being. You would be like boom, 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 you know. It would
whiplash everywhere.
You couldn't even hold the steering wheel if you're bumping around so much. All right. Again, this is Apollo 11, Apollo Flight Journal. This is the official NASA YouTube page. And this is what I call the dashboard cam. There's a video camera inside the ship looking down at Neil Armstrong's first steps on the moon. So now Buzz Aldrin comes out of the ship, and then you can see the two-man. For some reason, they play it back in fast speed, but anyway, we're just going to watch a second here. Blah, blah, blah. They're walking around. And then now you can see the length of their shadows. This guy has a long shadow, and this guy has a short shadow. Now, this is also very clear proof of stage lighting. You can see how it's very bright up here. The ground is bright, and over here the ground is dark, yes? So that we call a hot spot. This is where the light is pointing over here, and over here the light is less. So again, there's two proofs of a hoax here. One is that the light is bright. The second is that this guy's shadow is longer. So let me try to explain. This is a complicated point. So let me try to explain this. Imagine you have a stage light and two actors on the stage. So the actor which is closest to the stage light is going to have a longer shadow. Let's say everybody is familiar with this. If you're walking down the street and there's a street light, when you move towards the street light, your shadow gets shorter, shorter, shorter. And as you pass the street light, your shadow gets longer, 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 right? Everybody's familiar with that. That's because when you and the street light are at a 180-degree angle, you're just below the street light, you have almost no shadow. And then the further away you get from the street light, the shadow is going to get longer and longer. So it's the same thing now. If you tilt the light here, if you're standing over here towards the direction of the street light, your shadow is going to be short. And if you move closer to this, your shadow is going to be longer. This is called the obtuse angle. The more obtuse your angle is, the shorter your shadow will be. So if you're standing over here, your shadow will be shorter because it's more obtuse. And if you're getting closer, your shadow will be longer. This is a less obtuse angle. This is a very clear proof of a stage lighting, because if it was the sun, these two men would have the same length shadow, no matter where they're standing. Of course, the NASA trolls will try to come and say, well, the reason his shadow is longer is because of uneven ground. They always use this excuse. Oh, the ground is not even. That's why his shadow is not longer. No, it's totally nonsense. This is a flat ground they're standing on, and they're so close. There's not some kind of a hill he's standing on. No, it's not like that at all. All right, this is one most people are familiar. He falls down. Oh, and then the other guy, help me get up. Push on my head. And he just magically floats up.
He zapped some power into him.
So now I want to show you another clip where they're very close to the camera. And then it becomes very clear what's going on here. This is Apollo 16 from the EVA-1, Part 7. Here we go. He falls down. Uh-oh. Help me up, help me up. Now watch the other guy who's helping him up. He supposedly lifted him up. If you look at his hand, he's not even touching the other guy. His hand is, you see, he's not lifting him up. He's just getting up with the help of wires. The other guy's pretending that he's helping him up, okay?
No. There's no way.
But if you look carefully at his arm, he's not
even
helping
touching him.
up.
He's not even touching him.
He puts his arm there. They had practiced this. Okay, I'm going to pretend like I'm. He put his arm there like I am helping you up, but he's not giving any force at all to actually helping him up. So again, the NASA excuse is that the other guy is helping him up, but it's just not true. You know, you could, if you look carefully at these videos, he's not helping him up at all.
So silly.
Okay, so now we're coming into a series. This is a very important point here. This is my next smoking gun. And this is what I call NASA is caught with their hand in the cookie jar. It means that I am going to present you now with evidence that NASA is photoshopping their images in order to cover up the fact that they faked it. So I'm going to show you a series of images, and all these images are coming from Internet Archives. The reason is because Internet Archives is showing you the date in which this image was uploaded to the internet. Okay, so this is a record, an actual, you could use this in a court of law. You know, it's like, here's a record of when this image was uploaded to the internet. And this is important because the excuse NASA claims is that the photoshopped images came before the non-photoshopped images. What happened was, in 2000, 2001, these two documentaries came out. What happened in the moon was 2000. A funny thing happened on the way to the moon was 2001. After this time, NASA realized that they made a mistake. I first heard about the moon landing hoax in 2001. And the first thing I did was I went to the NASA webpage and I started downloading as many images as I could. A few years later, the NASA webpage disappeared. And then all of a sudden, in 2010, a new NASA webpage was built and all new photoshopped images. So what happened was in 2000, they realized they messed up. They said, we have to go back and fix these images because it's very clear proof of a hoax. So they removed the old webpage. It took them 10 years to Photoshop because there's hundreds, if not thousands of images they had to Photoshop. That took them 10 years to Photoshop all these things. You can see this, Internet Archives. Can you see the man on the moon?
Yeah, that's the original one, isn't it? And then they Photoshopped it?
Yes. So you can see how the bright light is here. And then as you go to the back, it's really dark. Yes. In the front is dark. And here it's super bright because of spotlight. Okay, this is not sunlight. And here, ta-da! It's fixed. The back is all lit up. They Photoshopped it, right?
Yeah, yeah.
So here we go. Look at the date. If you go down here, add date. 2010, July 16. Oh, interesting. They chose the anniversary. Okay, 2010 was when they made a whole new NASA webpage and they uploaded thousands of Photoshopped images in 2010.
Yeah.
So let's come back here to the original one. Here's the non-Photoshopped image. What is the add date? December of 2009. So this is very clear proof that the Internet Archives has the date which this was added to the internet. So this one came before the Photoshop one. You can prove this now in a court of law that this one came later, okay?
Yeah.
So I'm going to try to give you a few more examples of this because, we don't just want one image to go by here. Here we go. Can you see this one?
Yeah. One tiny little section is clearly lit up.
Well, like I'm saying, it's the same thing. You have the dark in the corners, and then here in the center is really bright where he's standing on the spotlight. What is the add date? 2009, right? Now let's go here to the Photoshopped one. Ta-da!
It's so ridiculously different. And so if you're a skeptic, you have to ask yourself, why go through all this damn trouble if...
Again, here's the add date, 2010. This came later, right? So what is the excuse NASA is giving for this? And some of the images, like for example, if you go to their Flickr page, where you can also download these images, and then you right-click on the image, and you go to image properties, it says this image was made by Photoshop. It says there on the image itself that this was made by Photoshop. So what is the excuse NASA is giving for this? I've had to deal with trolls, so I know their excuses. So NASA says that the reason is because we just so happen to use Photoshop as the program for our scanner. When we rescanned the images, the scanner was sending the images through Photoshop, but we weren't actually touching up the images. It's strange. See, the excuse they give is that, well, these old images was just a bad scan. So that's why we had to do a new scan. And in the new scan, we adjusted the light levels a little bit. But see, here's the point. At what point are you not editing the videos? Yeah, if you just change the light settings. But once you adjust the contrast, you are manipulating the images. If you're just doing light settings, but see, that won't do it. If you just change the contrast, then this will also be bright. Once you change the contrast, that's not going to do it. There's a tool on Photoshop which is called the lasso tool. And what you do is you lasso around the parts where you don't want to change. So the background, which is not under the lasso tool, you can adjust that while keeping this the same brightness. So this is how they did it. They used what's called the lasso tool, and they highlighted the areas they didn't want to change, and then they could change the other areas. So that's how they did it. Just a few days ago, one troll came into my group, and he said, well, that's not proof of Photoshop. And then he sent me a video of himself using Photoshop in order to make one used image look like the other image. It's like, wait a minute, you just use Photoshop to prove they didn't use Photoshop? Oh, it's so ridiculous. When the trolls try to debate these points, they're just making fools of themselves because these are non-debatable points. And I'm also, by using Internet Archives, I'm proving that these images are of an earlier date. Again, here's the famous flag salute. And you can see here, the ground over here is quite bright behind him. And the ground way back here in the corner is very dark, right? And now we're going to come to the new Photoshopped image. Ta-da! They brightened it up, you know, here in the background.
Yeah, everything is parallel now.
And again, the ad date, this is 2010, whereas if you go back to the original, 2009. So yes, definitely this one came before. Let's give a few more examples of this. All right, you can see this image, right? This is also Apollo 11. He sets up this little solar-powered thingamajig, whatever it is. And here's the spotlight is over here in the center of between him and the ship. And over here in the background is a very dark, right? You can see that, yes?
Yes.
All right, let's go to the new Photoshop image. Ta-da! All fixed up.
It's so drastic.
All even now.
It's a completely different picture.
Yeah, really fancy Photoshop work they're doing here. And again, the ad date, this is the Photoshopped one is 2010, and the non-Photoshopped one is 2009. Back in 2001, that's when I went to the NASA webpage. That's what I was downloading, you know.
Yeah.
But then they removed all the images from their webpage. So back in 2001, this is what you got from the NASA webpage. But after 2010, wow, everything's all fixed.
Yeah, yeah.
All right, let me just show you just the last couple ones, just to prove that this is not only Apollo 11. Okay, it's also other missions. Here we go, Apollo 12. Here's the spotlight, yes. And over here it's very dark, and over here it's very bright, yes. This one was added a little later, but this is the Apollo 12 image that hasn't been photoshopped. If you go to the new NASA webpage, you can find the photoshopped one. Now I'm taking you to the NASA webpage. This is an image they forgot to Photoshop, which you can find it directly on the NASA webpage now. 5866. So here we are in the Apollo webpage, right? This is the AS11-40-5866. Here's the high resolution one here. And now you look under the ship. It's really bright, yes? And here in the back, it's dark. So this is one they forgot to Photoshop. If you go to the original, it is a little bit darker here. But here it's super bright. And this is coming directly from the NASA webpage itself. So it means they didn't do a very good job photoshopping this one. This brightness under the ship should be the same brightness over here in the background. So they didn't do a very good job photoshopping that one. So that is the presentation on the photoshopping of images. The next one is the famous hitting the rock. He's banging on the rock, and you can hear the banging sound coming through to the microphone inside of his suit. So sound cannot travel through a vacuum. You shouldn't be able to hear this banging sound in his suit. Now, some people ask me, they say, well, maybe it's just the vibrations coming through the suit up to the microphone, but that's not possible because he's not wearing a solid suit. If you were inside like a solid tin can, and you knocked one part of the tin can, yes, that sound would reverberate through the tin can. But the suit is flexible, right? So the sound cannot reverberate in a flexible suit like that. So let's just play this video clip. Apollo 17, this is the official NASA webpage. And this is the clip, the time, 114 hours, 40 minutes, unto 122 hours, 40 minutes. And you have to fast forward all the way here to 7 hours, 31 minutes into the video. I like to show people the exact references here, okay?
Yeah.
Because this is something a lot of the people in the past forgot to do. Please, if you find a smoking gun, show us where you found it. And this is coming from official NASA webpage. So I'm going to show this thing where he's banging on the rock. Here we go.
That's good, G.
Here you can hear it. Tuck,
That's good, G.
tuck, tuck,
Don't wear your hand out.
tuck, tuck, tuck. So there's many different examples where you hear one tuck like that, you know, like he falls down and he hits something and it's like a tuck. Or there's another scene where he throws the hammer and it hits the ship and it's like tuck. You can hear it tick and hit the thing. Now, if it's just one ticking sound, you can make an excuse like, oh, this was just a microphone problem, and it just so happened the microphone made this tick sound at the same time that the object hit. But here we have 4 tick sounds, okay? So it's a little bit hard to explain because many times he's hitting the rock, you don't hear it. But that's because his hammer is not making a solid hit onto the rock.
Don't wear your hand out.
But there's 4 times where it's like you hear tuck, tuck, and then he says, wait a minute, let me try again. Tuck, tuck. So there's 4 times where his hammer makes a really solid contact on the rock, and that sound actually comes up. So that's why I'm saying this is the best example of these hearing sounds. It's because it's not just one tick sound you hear, but there's 4 ticking sounds. All right, let's keep going. I'm going to go to the next smoking gun here. This is what I call the lack of delay. The recording of the audio is being done on Earth. So if somebody at Mission Control says something, like he's going to ask a question, so his question will go out, and that takes 1.3 seconds for the speed of light to reach the moon. And then when the astronaut hears that, he replies, and it's going to take 1.3 seconds for his reply to come back. This is a 2.6 second delay. Must be there. But the delay must come between when Earth says something and when the reply comes back. Okay, that's where the delay has to be there. Now, there are many examples of this. For example, American Moon does a really good job of showing different examples of this, but they forget to tell us where these clips are. Please, if you find a smoking gun, tell us where you found it. So I'm going to tell you now where I found some very clear examples of this missing delay time. And these are on the rover drive of Apollo 15. And I'm going to try to point out exactly where these missing delay times are. I'm just going to play this clip and I'll try to point out when does Mission Control say something and when does the moon reply. So you can hear it.
We'll advise you on what your rate looks like and the tasks that we want you to carry out once you arrive. Just start off in the direction of Station 4, please. Okay, and standing by for a mark when you roll. Dave, you'll want to trend for course 346, and it's about 1.7 clicks to station.
Okay.
And you're running at 12 frames per second, I imagine.
Yeah. Right.
But Jim might want to swing the camera around towards the right.
We're heading directly downhill now. We're not
Roger, Jim. Copy. Any idea of the dimension?
Actually, I'd estimate it's relatively thin, but
What kind of progress are you making now, Jim?
we're going at about 0.8 clicks. Oh, 8.
Okay, so Spacecraft Films was the original DVD where they got all the original clips from NASA and they released official DVDs. So that's where this guy's YouTube page, he's just taking his clips from Spacecraft Films. And Spacecraft Films are the original unedited video clips. So now you can see this. This is the ISS spacewalk, right? Now, the thing you're looking at here is the sun reflecting in his visor. You understand? You're looking in the face mask, the visor of the astronaut, and then you can see the sun. I'm going to go to full screen. We can watch the sun on the ISS spacewalk. See the sun? He puts down the visor. Again, you see the sun's reflection. Now we're coming over here to Apollo. I'm going to show you the sun's reflection here. Oh, look how big that sun is. It's a huge stage light. The excuse NASA will make is something like, well, it depends on the angle of the curvature of the visor. But that's not true, because in both images I'm showing you the same angle of the same visor. In the ISS, same visor curvature, same angle of the sun. So you can't make that excuse. Now, we've got our last two smoking guns. What we're looking at is the exhaust coming from the booster rockets. You can see this chemical equation, C2H12N4 plus N2O4 equals CON2 plus H2O. So this is the chemical equation of what's called the hypergolic fuel. This is the fuel which NASA using on the Apollo missions. This N2O4, this is called the oxidizer. It's providing oxygen to the fuel. And this is the reaction. CO is carbon monoxide, and then you have nitrogen gas, and then you have H2O, which is water. So carbon monoxide is the invisible gas. So you don't see carbon monoxide, and you don't see nitrogen. These are invisible gases. But H2O is steam. So what you expect to see when the ship fires its engine is you expect to see steam coming out. And I'm going to now show you examples of that. Is here on the Soyuz spacecraft docking with the ISS. And I'm going to show you the steam coming out of the boosters, the rockets. Here we go. Watch the steam. You can see the blast of steam, right? Yes? So there you go. That's the steam. Now we come here. I'm just giving another example.
The digital sparks.
Right. So the point I'm trying to make here is that you should see steam coming out of the bottom of this engine. On the Apollo Detective channel, this friend of mine who's making that channel, he is a Hollywood expert. He works in Hollywood. So the technical name for what they're doing here is called a shrapnel cannon. These are actually little chunks which are being ejected with the use of explosives. The reason they look like rainbow sparkles is because of the type of TV camera they were using. It's a 3-color red, green, blue TV camera. So when something passes quickly, it leaves these rainbow sparkles. That's just the effect of the TV camera. So the way they fake this is they lifted the ship up with a crane, and then they had this shrapnel cannon firing all these little bits and pieces of stuff in all these different directions. The Apollo trolls, they like to mention this little triangle here on the bottom. There's a triangle here on the bottom. You can see it, right? They're saying this is the blast. This proves it was real. But this is the result of the shrapnel cannons. There is also a little bit of dust. So you can see dust flying up here. So again, the apologists like to say, oh, that's proof that this is real. But coming back to it, despite all of that, you should see a huge gusts of steam coming out of the bottom of this craft. That is a result of the chemical reaction, is that huge gusts of steam. You see, when you come back to the Soyuz missions, you see the steam gusting out, but this is just tiny little bursts of steam. But here we're talking about an actual liftoff. So the amount of fuel using on this liftoff is thousands of times more than that little course correction little bursts of steam. So you should see huge gusts of steam. And of course, the NASA excuse will be like, well, this has to do with the dispersion of the steam into the space. Now let's come to the last smoking gun here. So this is the Chinese Mars lander. And you can see there's a huge hole in the ground where the exhaust was blasting a hole and blowing out all the rocks as the ship was coming down. You can see that huge hole, right?
Yep.
So this is what you would expect to see. Let me kind of do a little more detail on this. This is the Chinese Mars lander. You can see the hole very clearly. There's also a NASA Mars lander where they have a camera. They put the camera under the ship, and you can see where all the dust was blown away by the landing. So just to add this in, some people asked me then, said, well, what about the Chinese moon lander? The Chinese moon lander does not have this blast crater because the Chinese moon lander dropped from a very high height, okay? But the Chinese Mars lander, it kept the engine running all the way until the surface. And that's what happened on the Apollo missions as well. That's why the Apollo mission should also have this huge blast crater. This is just a tiny little ship compared to the Apollo missions. So the blast crater should be much bigger than this. This is just a tiny little Chinese unmanned craft. So here's a link. This comes from, but this is just a little gem which Jero White found. It's on his channel.
A big question here is like, can you land on the moon with the main engines? Or do you need a separate thruster system that's way up there? Like basically, if you land with the main engine, are you going to dig a big ditch in the moon and then fall over because you landed in a ditch that you dug?
Now, this is a very funny point. This is a webpage where it's called Height Above the Surface at Engine Shutdown. Collect space, and a bunch of NASA fanboys are talking about all the details. How high were they above the surface when they shut down the engines? And they're giving all these different figures. Oh, he shut it down. And they talk about the speed. How hard did the ship land? You know, they say Apollo 15 was the hardest landing. They cut the engines off at a little bit higher altitude so that when the ship actually hit, it hit harder. And it hit so hard that the engine actually hit the ground. And it even distorted the engine bell as the engine bell hit the ground. So all these intellectual guys are examining all the Apollo landing sites, and they're calculating how hard did the ship hit and how high was the ship when they cut off the engines. And none of them are mentioning the fact that there should be a blast crater. There should be a hole in the ground due to the exhaust. Now, they do offer one picture. I'm going to just click here on this NASA image. So here's the funny thing. All these intellectuals are saying, wow, you can see the dust has been blown here. You can see the dust has been blown. I see no blast crater. There should be a huge hole underground. So you can see a little bit. It looks like they maybe took a leaf blower or something. If you really kind of imagine hard, you use your imagination, there should be a huge blast crater under this engine because this is an extremely heavy craft. The NASA excuse is that, oh, the reason there's no blast crater is because throttle down. But even with throttle down, there still should be a huge blast crater, you know, because even here on the Chinese one, you can see this is just a tiny craft, and even with their throttle down, it leaves this huge hole in the ground. This is the 12 smoking guns, and like I said, there are more than 12, and I'm just showing you a few examples for each one of these 12 smoking guns.